One of my primary goals that I'm learning OpenGL is that I want to express my mathematical ideas through OpenGL. For example, I want to express vector field. Vector field. If you scroll down, you can find graphical representation of vector field. These vector fields can represent many different things. These vector fields can represent electromagnetic field, or flow, or flux. I want to express such vector quantities using OpenGL. To do this, we need to be able to pass not only vertex information, but also we have to be able to pass normal vectors on a surface. To do this, we have to learn OpenGL. From this book, listing 5.8 multiple interleaved vertex attributes. This code, listing 5.8 multiple interleaved vertex attributes. Please understand that this code snippet has some bug, especially this is bug. This is also bug, but don't worry. If you read this text, everything is explained in detail, even though the code snippet has some bugs. We will learn how to use VertexArrayVertexBuffer. We have to provide stride parameter. The stride parameter tells OpenGL how far apart in bytes the beginning of each vertex data is. If we leave it as 0, OpenGL will use the same data for every vertex. However, to use vertex structure declared above, we can simply use size of vertex for the stride parameter, and everything will work out. If you read this text, you can easily figure out what's the problem in this code. If you want to follow my current session, you may have watched my previous videos in this playlist. C++ 17, 20, 23, CUDA, SQL, OpenGL, OpenCL, TBB. From this playlist, I assume you have watched my previous videos listed here, especially episode 96. From this video, click Show More. Download current videos source code. Click this link. Show in folder. Unzip it. Rename 097. Copy. Paste it in your working directory. From this folder, double-click multiple buffers. From Solution Explorer, I will pin down. Right-click, set as Startup Project, press Ctrl F5. We implemented this program in our previous episode, episode 94, 95, then 96. In this case, we implemented listing 5.7 multiple separate vertex attributes. So, we implemented listing 5.7. Now, save all, right-click the solution, add new project, select OpenGL Survival 7. Click Next. Accept default. Click Create. Right-click, Set as Startup. Now we can close this source file. Press Ctrl F5. We should build successfully. Now close it. We will fill out this file. Now in the File Explorer, make sure in your C++ 17, 20, 23 parallel working directory folder 097 OpenGL SB73. From this folder, we will copy two files. Copy points fragment, points vertex. Now go up 097 again, SB74, paste. In the Visual Studio, right-click Shader Files, add existing item. Please watch carefully. Folder 97, OpenGL Supervival 74. Select points, fragment, points, vertex. Click Add. We created this file in our previous episode. I will arrange side by side and auto hide. Please understand that we will implement listing 5.8 multiple interleaved vertex attributes. Please refer to this documentation in this PDF. Here, public, we will define struct vertex GL plot x, y, z, GL plot r, g, b. This is for position. This is for color. We need to build our shaders. This program create program. We pass this vertex shader points but copy, paste, fragment. Of course, we need to define program. I will create here private GL name T program. We initialize with the default value. Then GL use program. This program. Check GL operation. Failed to build shader program. We need to extract attribute index for position and for color. So GL int attribute index position, we will initialize -1. GL attribute index color. Now here this attrib index position gl get attrib location. This program, we provide this attribute as a string. Throw if true. If this attribute position is -1, failed to retrieve attribute position. Copy, paste. This is attribute index color. We should provide this color. Also, copy, paste. We used these functions so many times in our previous episode. Now, GL plot center 0.0 F, GL plot left -0.7 F, right +0.7 F. Copy, paste, bottom, top. Now, static constant vertex. This vertex is type defined here. It requires 6 floats. So, we say vertices semicolon. We can provide left, bottom 0.0 F. Copy, paste. This is color. Copy, paste. This is right. Bottom, copy, paste. 5. Copy, paste. This is center, top. Center, top. Remove trailing comma. I will arrange like this. I will give a tab. Then I arranged like this. Of course, we can do this too. We can do this too. Because this is one vertex, 2 vertices, 3 vertices. I will give one more tab. Position, color. Now here, GL create vertex arrays. We create one vertex array. This vertex array object. Of course, we have to declare GL name T paste, copy, paste, vertex buffer object. Now scroll down. We created vertex array. Check GL operation Step 1. GL create buffers. We create one buffer. Vertex buffer object. Copy this. Paste. This is step 2. We initialize this buffer for buffer object. GL named buffer storage. The first comes buffer, this buffer. Then follows size. This is byte count of the buffer to allocate. We want to hold this array, so size of vertices. This is byte count. We initialize with vertices. Then flags. We use default value. Copy, paste. It is step 3. Now we set attribute for position. For attribute vPosition. Scroll up. GL Vertex Array attrib binding. This is Vertex Array object. Vertex Array object. Attribute index for vPosition. We retrieved attrib indexion position. So we pass it here. Then binding index. We can set any value as long as it matches with some other function. We set binding index to 0. Now this is step 4. Then GL Vertex Array attrib format. It requires Vertex Array object. Vertex Array object. Then attribute index. We are setting attribute position. I would say this to make it clear. Then size. This is element count for position. This is back 3. It has 3 elements. 3. Then type. GL float. Then normalized. GL false. Relative offset. We use offset of macro. Okay. From this structure, vertex structure, we want offset of x. So vertex offset x. This is macro. I will give a line break here. Don't miss semicolon. This is step 5. Please understand that we are setting attribute index for position. This is vertex value of type back 3. So 3 elements. In this structure, first 3 values are for position. Its offset. The offset of x is represented with this macro, offset of macro. Now GL enable vertex array attrib. this vertex array object, vertex array object. Then index. This index means attribute index. So we provide attribute index position. This is step 6. Now we set for attribute v color. We have to repeat this process. GL vertex array attrib binding. We pass this vertex array object. Now we pass attribute index for color. So this attribute index color. Then binding index. We have only one buffer, so we pass 0. This binding index and this binding index should match. Okay, in this case we sent attribute index position, attribute index color, because we have only one buffer. We pass value 0. I will copy, paste. This is step 7. Now GL vertex array attrib format. We pass this vertex array object. Then attrib index. This attrib index color. Size. Each color has 3 elements, so 3. Then type GL float, normalized GL pulse, relative offset, offset over vertex. Now scroll up. In this case, the starting member is R, so we should provide offset of R like this. Here, offset R. I will give line break here. Now this is step 8. We need to GL enable vertex array attrib. This vertex array object. Then index. This is colors attribute index. This attribute index color. So this is step 9. Now common part. Common part. We need GL vertex array vertex buffer. This vertex array object. Then binding index. We will simply provide 0. Then buffer. This vertex buffer object. Then offset. This offset starts with 0. Then stride. In this case, from one vertex to next vertex, there are 1, 2, 3, 4, 5, 6 elements. So 6 plot. For example, here, this is one vertex, 2 vertices, 3 vertices. The first is for position, the second is for color. So 6 plots. We can say size of GL plot 6. Don't miss closing parentheses. This is step 10. Step 10. I emphasized this part. I cannot emphasize that we should never forget GL find vertex array. I mentioned this part in my previous episode. GL find vertex array. This vertex array. You should not miss this. Now I will remove some space. So this is step 11. Never forget this. Now scroll down. In the draw function, GL draw arrays, GL triangles. First index is 0. This is vertex count. We have 1, 2, 3, 3 vertices. So we have to provide 3. Sorry, this is not triangle, triangles. Like this. Now press Ctrl F5. It should build and run successfully. Now close it. Instead of doing this, this is stride. In this documentation, I will make it bigger. You can read more about stride. I will copy this up to this point. Copy, paste it here. It says we can simply use size of vertex for the stride parameter. This is the stride parameter. I will delete it. Instead, paste vertex. Press Ctrl F5. It works perfectly as previously. Now close it. Please understand, in this listing, this is error. This is also error. Please compare this code with my own implementation.